one or two latecomers. Right, so my name's Andy Davies. I'm an English guy living in Finland, which is interesting. I work for a financial tech company. We are a debt collector, but we're really nice, honest. We actually try and help you buy stuff, but we'll only let you borrow money from us if we think you're actually going to be able to pay it back. So we try to be responsible. And this is talk about feature toggles and some of how we've used them and stories of how other companies have used them and how things have gone really well and in some cases gone really, really terribly for companies. And as everyone loves a horror story, we're going to start with that. So who's heard of a company called Knight Capital? I'm guessing from the giggles a few of you. And does anyone want to shout out why they've heard of Knight Capital? PowerPeg. Exactly, PowerPeg. We'll get to what that is exactly in a minute. I'm always looking forward to the day when I do this talk and someone who worked there is in the audience. Because either I'll have to avoid them or buy them a beer. I don't know which. So a lot has been written about this company because they had a series of little mistakes which if they'd solved any one of them, they could have probably avoided their little catastrophe. So for those who don't know who Knight Capital are, they were a financial services company. They were doing high-frequency market trading and market making, which is, I assume, what caused the credit crisis. So I'm not that bothered that they are a not existing company anymore. Now, before this story starts, they had about $365 million worth of assets available to them. So you need to keep that number in mind. So this is their share price graph when this incident happened, and you'll notice there's quite a drop on one side. This is also a logarithmic scale, so it's a really big drop. And while that's happening on a date line between August 1st and August 2nd, it didn't take a day for this to happen. This was a 45-minute window. So, how did they manage to lose this much share price in 45 minutes? Well, it comes down to two features. They had a feature called PowerPeg and a feature called SMARS. Now, PowerPeg was an existing feature that had been unused and was behind a feature flag in their code base for around 8 years. Quite why you have code that's not used for 8 years is beyond me, but either way, that's how old it was. Now, what this code would do is that when a large order came in, it would take the order and split it into many subsequent orders and just keep sending out orders and counting them until the right number had been fulfilled. The problem is, the part of the pipeline that did the counting of orders had been moved much earlier on into the pipeline, so this code could no longer work even if it was activated. But they not used it in 8 years, so it didn't matter. So they wrote a new feature called SMARS, which did a similar functionality. It split big orders into smaller orders, but not in the same manner. And as PowerPeg was being replaced with SMARS, they reused the feature toggle. So if we look at this code sample, we have a feature flag at the top, which is if feature enabled, which is a really bad name, by the way. We will submit a new order, like one order for every item in this main order until we've hit the total number of orders submitted, until we've submitted the total number required. If the feature flag is not enabled, we're going to call the submit new order function and just say, get me everything in the order. Now, I should point out this is me guessing how their code was formed to work out based on all of the stories of what's happened, because obviously they haven't released it. They should have open sourced everything afterwards, and we could have all had a laugh. Now, what happened at some point is they've done some kind of optimization that's moved where the counting happens. Now, if you look in the old version, whenever we submit new order, we increment the current count of how many orders have been submitted. New version, that doesn't happen in that function anymore. It happens at the end of the call. We just say the current number of orders is some count that we've fetched from somewhere else. Then they replaced it with this SMARS feature. And this submit new order is still doing the order submission magic, but the current count is still being added at the end. Now, if you switch on this feature flag, we're going to call this split into smaller orders function, and everything's going to work fine. That's the new SMARS feature. But if you were to switch on the older PowerPeg feature, everything's going to go hilariously wrong. Now, because they were testing things, they deployed it to QA. They're using feature toggles, so they deploy it to QA, they test that their new feature works, and it does. Well, obviously, they wouldn't have deployed it if it didn't work. So as they're using feature toggles, they do a dark deployment to production, which is symbolized by the yellow things. Now, you might notice that one of these squares is blue still, and that's because their deployment pipeline deployed to 8 servers but didn't report any failed deployments to them. So they actually only deployed to 7 servers, not 8. So what do you think happens when you switch on a feature flag that's being used for 2 features in different versions of software? 7 of them are doing the new splitting into orders thing, which is fine. The 8th server, however, is now trying to fulfill orders without being able to count how many orders it's submitted as fast as it possibly can, which is bad. So they did the logical thing, if you're not using feature toggles. When a release goes bad, what do? You roll back. And now you've got 8 servers going really fast, doing the wrong thing, which is worse. And then a few minutes later, I think it was 10 in the report, they switched it off and switched off the feature flag, and now all their servers go back to not doing anything bad. Now, unfortunately, in that 45-minute window, they lost $450 million, and they only had 365 to start with. So they don't exist as a company anymore. So yeah, I guess the first rule from this comes out as never reuse a feature toggle. Because if they hadn't reused a feature toggle, what would have happened if they had a new feature called like enable PowerPeg rather than just enable thing? When they switched it on, 7 servers would have started doing the new operation. 1 server would have just not done anything because its flag's not been changed. But they didn't. They reused the flag and all hell broke loose. The second part of it is dead code. I mean, PowerPeg hadn't been used for 8 years. Why is it still in your code base? I mean, I hope they had source control. I don't have anything to say they did or didn't for sure. But if they had source control, just delete it. You can always get it back from history if you need it. So this also follows on into the next rule, which is keep your toggle lifespans short. Because a long lifespan toggle, you're more likely to hit into things where this toggle has been off for a long time. And it still compiles, but when you switch it on, it doesn't work the same anymore because the surrounding code has changed in a way that assumptions that were written, or assumptions had when that toggle was written, are no longer valid. So the longer your toggle lives for, the more likely you are to have this kind of problem. So keep your toggle lifetime short. I mean, ideally we're talking days, maybe weeks, but not years. Okay, good. That's displaying weirdly on my screen. The next point is naming of feature toggles. Now, in my piece of example code, it was just called enable feature, which is to get the point across that that was a terrible name. If you look at these 4 names for feature toggles, the first 2, pretty descriptive. The next one, well, okay, it's a Jira ticket number, so it is probably unique, but you should probably include some textual description in that as well. And the final one of just enable new feature is terrible. You're not going to see what that's for. So if someone has repurposed your toggle, and then you're in a UI and right, I'm going to switch on the new feature. What is a new feature? You don't know. You're going to switch it on and probably it'll work, but maybe not. So yeah, rule 3, name your toggles well. So now that we've covered a company that did something really terrible with toggles, let's talk about different types of toggles. Now, toggles can be used for multiple different purposes, which we'll go through in a minute, but basically the further on the right-hand side of this you are, the more flexible your toggle is, down to the left-hand side when it's not very flexible at all. So a compile time toggle is generally something you're only going to use for debug flags. So for instance, we have a SQL profiler, and that'll only be compiled into the application if you have the particular flag switched on for it, because we don't want that in our production application. And the only few times we need it, it's fine to just recompile with the flag switched on. Startup toggles tend to be the ones that you use the most with microservices, because you only need to read your toggles once on startup, and then if your toggle values change, you can just restart the service. Hopefully you've got multiple copies of the service running, so you can do a phased deployment and not have any downtime. Periodic toggles happen in the background, so you can query it regularly, and whenever your action happens, you can look at the toggle and you'll have a fairly current state on things. And finally, you've got an activity toggle, which is, say, every time a page is rendered or a user clicks a button, you'll be checking the state of the toggle to see if it's on or not. When you're actually using an activity toggle, you're probably actually using a periodic one, because you don't want to incur the latency of, well, you're probably going to be using launch darkly. You don't want to incur the latency of having to query their server every call for every time you render a page, because that's going to slow your page rendering down. But now that we've looked at some feature toggle types, I'm going to look at a company that's changed what type of toggle they were using for great benefit. So who's heard of HP? Okay, everyone has, right. In this case, we're going to be looking at their printer firmware division. Now, their firmware division was made up from about 400 to 800 software developers spread around the world. They had over 10 million lines of code, and they managed around 2 releases per year, and engineers on average spent about 5% of their time writing new features, and 95% not. The breakdown of that was things like timesheets, merging, trying to fix things that they'd broken earlier. And the reason it was fixing things and breaking earlier was because when you had your change ready and you pushed it to the master branch to get things merged and built, the feedback cycle on that was 8 weeks. I don't know about you, but if someone checks in something broken and it takes 8 weeks for feedback to come back, and someone goes, hey, you broke the build 8 weeks ago, I don't remember that. And the likelihood is someone else has taken a branch off it by that point anyway, so now you've broken multiple builds. The other problem they had was an insane branching strategy. So roughly speaking, they had a branching strategy per printer series, which usually aligned with quarters of the year. And what they would do is they'd create a new branch for their new printer series, and then they'd change all of the if-defs, which were scattered throughout the code base. This is compile time toggles, for each printer to say what functionality it had and whether they should enable things like scanning or double-siding or that kind of thing. They also made bug fixes, which are our red diamonds in here. Now, of course, bug fixes need to be on each branch because they might affect other printers. One thing I should point out as well is each one of these branches had a separate build pipeline. So you still had the 8 weeks on each branch. So when you take a bug fix and you port it, and hopefully you only port the bug fix and not all of the if-def changes, because otherwise you're going to break another printer, you end up with merging that looks something like that. And now you can see why they spend 95% of their time not writing features. So what they decided to do is re-architect their entire system to make it one piece of firmware that would run on all printers. And rather than have a separate build with different if-defs everywhere, they would have a configuration file. And that configuration file on startup, the firmware would first read from the printer what model it was, find the appropriate configuration file, and read all the config flags out of that, which gave them this branching strategy. So bug fixes are happening and are being committed fairly quickly, and new features can be added in slightly longer lived branches, which would also include updating the config files to say, I've added a double-siding module and we know that this printer, this printer, and this printer supports it, so I've set that config up. Also, new printers can just be added and merged in as they go. So they've switched from compile time toggles to startup toggles with this. They also switched to trunk-based development, which is great, and you should all be doing it. And by doing this, their cycle time went from 8 weeks down to 2 days. I mean, they made some other improvements too, like they have multi-phase builds, so things go through like a unit testing phase, then it goes to integration testing, and then emulator testing, and then something else that I forget the name of. Simulators, then emulators. One of them is a fake printer that's real, and one of them's a fake printer that's virtual. I can't remember which way around it is. So you test on a virtual printer, and then once your virtual printer tests pass, then you give it to a real printer that doesn't actually spray ink everywhere, it's just the controller board. So the tests got slower the further through it went, which meant that when your build or your change broke, hopefully it would be caught in one of the earlier gates. You wouldn't be waiting the full 2 days anyway. So the outcome of this is really that your architecture matters. You can do feature toggles by scattering if statements throughout your code base everywhere, but please don't. It's one of the biggest pushbacks against feature toggles that I hear, is that people don't want if statements everywhere. They don't want this scattered throughout their code base, which is great, because it shouldn't be. There are many other ways of dealing with feature toggles so that each toggle should only be queried maybe once or twice in your entire code base. The way you get, HP got this. They architect their system in a way that this worked. Knight Capital, I don't know. They haven't said how they use their feature toggles, but I'm imagining not well. So I'm going to pretend that Knight Capital have them spread everywhere in their code base, or did beforehand. So the way you get around this is branching by abstraction. Now, if you're doing trunk-based delivery, you're probably going to have to be doing this anyway. But essentially, rather than having a branch for a feature, you branch by inserting an interface or something to provide a different implementation of some part of your system based on whether the toggle is on or off. So this example we'll use a few times throughout this presentation, and it is based on a real-world system that I had to modify. So we have an email connector interface, which has a single dispatch method, and given an email message, we'll probably dispatch it somewhere. We have two implementations for it. The first one is a web service connector, which we'll get to later, because it's terrible, and a RabbitMQ connector, which is better. Now, when it comes to rolling this out, we don't want to give this to everyone straight away, and we certainly don't want the whole code base to have to check which implementation it should be using. So this is using structure map, or technically Lemma, I guess. You can't really tell. But in our startup of our application, we're configuring our container to say, if this toggle is enabled, use RabbitMQ, otherwise use the web service connector. Now the rest of the code base that requires the use of an email connector can just ask for an iEmail connector and it'll get the relevant implementation. Should be noted that when we did this, the existing calls to the web service-based email connector were scattered everywhere through a very large monolith code base. So our first set of releases was actually refactoring things down until there was just one class that dealt with talking to it. So you can't necessarily just deploy once with this. So we did a deployment that refactored things, then a deployment that added the interfaces, and then deployments that had various implementations of the feature toggle and different implementations. This works great for startup toggles, because we only need to query it and configure it once. However, if you want your toggle to be queried more often, and generally the more risky a toggle is, the more often you want to query it, because if it's a big risk and something breaks, you want to switch it off fairly quickly. So in the case of that, you can just use something like the factory or the decorator pattern. So we have a generic form of this in the codebase. You give it two implementations, and that way when you call dispatch, and this is a specific version, but a generic version of this takes in two implementations of anything, and will let you pick which one at call time of dispatch. And then if your toggle library is fetching the states in the background. Yeah. But this doesn't just have to be for back-end code. We can use feature toggles in front-end. So this is a little example which is vaguely written in React. So we have an actions panel on our web shop front-end, and we've got 3 buttons in it: one-click buy, add to cart, and add to wishlist. Now, one of these has a feature toggle controlling whether it will actually show up, and you can't tell which one it is from this code. It's probably the one-click, because you probably don't have a patent grant from Amazon and they won't like you having one-click buy now. So the one-click is actually implemented like this. This is a made-up feature toggling library, by the way. Don't try and find it. It probably exists by the time I finish speaking. One of you is writing it now, I can see. So the idea is you write your single button and then you wrap it in a function that checks the toggle for you, and then export that, and nothing else in the codebase needs to worry about where that toggle is queried. So this can work in UIs as well. Again, it all comes down to careful design and architecting your system well. You can just use if statements if you have to, but I'd really rather you didn't. So as I've mentioned a few times, toggles can be used for different things. So this little graph covers where toggles can be used and how flexible they are. So we've already covered the bottom axis, and up the side we've got our 4 different types of toggle usage. The first one is a release toggle. This one is generally when you're deploying a new feature and you want to give it to either a group of people or maybe everyone at once. So if you've got a new implementation of something and you just want to switch it on for everyone on a certain day. The experiment toggle is pretty similar to the release toggle, but is generally more used for A/B testing. So maybe you want to check if a green buy it now button makes more people click it than a red buy it now button. It does the same thing, but you probably need more monitoring in place so you can keep an eye on whether your experiment is actually proving something one way or the other. Again, this should be a fairly short-lived thing because it's a small feature test. Ops toggles we use for performance. So if we've got a heavyweight service that causes a lot of load and we want to switch it off sometimes if our SQL server's dying for other reasons, then you'd use an ops toggle to switch off the feature. These tend to be the longest lived toggles because I don't know if you can technically call them feature toggles because you are switching on and off a feature, but they do tend to be longer lived than the others. Finally, you've got permissions, and the only thing to say on this is don't. You can do permissioning with feature toggles, but don't. You're kind of mixing meanings of things. You really should be using an authorization service for this. Something like Identity Server or Keycloak would work great for this. The only time I'd allow you to put a permission toggle in is if you didn't have one of those 2 servers and you needed something out now and you already had feature toggles available. But I'd say you're incurring a fairly high level of technical debt for that. Especially if it's permission-based, you're implying that it's going to live for a fairly long time. Because you're not going to suddenly give has the permission to delete all the users. You're not going to suddenly remove the flag around there. Yeah, everyone can delete users, they'll be fine. So yeah, don't do permissions. So operations toggles tend to sit on the right-hand side of this. A compile time toggle would not be much use for something that you want to switch on and off for performance reasons, because you'd have to rebuild the application and then deploy a new version of it, and by that point, maybe your performance problem's gone away anyway. As an example of this, we had, in a previous company, a background process that really caused quite a lot of load on the database. Not enough to cause issues, but if there were other things happening, then this was an easy candidate to switch off. And we'd then get a bunch of spare capacity on the server for everything else to run, and then later on we could switch it back on again. Now, because we needed to keep an eye on this, we started off with a performance monitor which would switch on and off the toggle. Now, this performance monitor is the most complicated piece of software ever written by anyone ever. It's the DBA. You try writing a brain. So yeah, he would keep an eye on the database, and if the performance went bad, he'd just switch off the toggle for a while. Now, eventually, we wanted to automate this, because having the DBA watch the CPU graph is not the best use of his time. And when you want to automate this kind of thing, you really need to monitor your background process and your toggle usage. Because while this background process can be off for a while, with no users noticing the impact of it, if you're switching it on and off repeatedly, if the toggle's flapping a lot, then it's never going to actually complete a run, and people will eventually start, well, why is my data not here? So when we eventually automated it, we also had monitoring dashboards, and we'll get into monitoring and what you need to watch on toggles later. Yep, that's all for that one. So that's an operations toggle. So the next one is an experiment. Now, an experiment can move slightly further to the left, because again, with microservices, you can just bounce the service to change the state of the toggle if you're reading on startup. Generally, with an experiment, the bigger the risk, the further to the right-hand side of this graph you want to be. Because again, if you're just checking the color of a button affects click rate, then maybe you can get away with the startup toggle for that, because you're not really going to have that much impact on the business unless maybe you've made the button completely invisible, which would probably lower your click rate. But if it's a fairly high-risk feature, like, I don't know, PowerPeg or Smarts, for instance, you'd probably want that on an activity toggle, where you could switch it on and off very quickly. Finally, release toggles, again, they tend to shift slightly further to the left. If you're rolling out a feature, you don't tend to need it to be checked on every activity. So a background check to a compile check is probably fine. Yeah, so let's have a look at an example of use of rollout. This was a release toggle rather than an experiment, although we did use it as an experiment to start with. So as I mentioned earlier, the email connector example. We had a SOAP service for sending emails, which sent them via Exchange. The SOAP service was terrible, and Exchange was terrible, and the application was terrible. So it's a recipe for success. So for some reason, like if there was any problem sending, you ended up with a horrible, gigantic XML error in the application. The SOAP service did a lot of magic, like reformatting emails, adding headers, deleting things, detecting you if you're in dev mode, that kind of thing. And also Exchange would take about 800 milliseconds to send an email usually, except for one half-an-hour window which shifted during the day. So every day you could see in the log graphs the window shifting earlier. For half an hour every day it would take 30 seconds to send an email, and I have no idea why. I never got to the bottom of that. Which was probably what caused a lot of these errors to come through to the application, because the application is not expecting an email to take 30 seconds to send. No one expects an email to take 30 seconds to send. So our plan was to replace this with RabbitMQ. So our first release was refactoring so that we had these connectors at the beginning, on the left-hand side of this graph. And we had a feature toggle to switch between whether you use the old connector or the new connector. Now the new connector was implemented as, I think, 5 or 6 decorators. So the decorators actually took the logic of what the SOAP service did and put each part into a separate decorator, because then each part was testable, rather than being one giant function in an XML SOAP service. Now, what would happen with the RabbitMQ connector is it would take the mail message, format it, dump it onto RabbitMQ, and then we had a worker service reading it off as fast as it could and sending them. We also lied to the user at this point as well, because the old service would send the email, wait for 30 seconds, and then say, hey, success, or more likely, failure. Whereas with the new one, we just went, yeah, it's been sent. No one cares, as long as it doesn't take that long to send. Now, because this is affecting an entire internal CRM system of a company with maybe 500 users or so, we didn't want to just switch it over to the new system in case the new system didn't quite work, because we've pulled a lot of logic out of this SOAP service as well. So what we did is we went to one particular user who had the most problems. He was also one of the biggest pain in the asses to deal with at that company. He complained about everything, which meant he gave feedback on everything, which means that when you're experimenting something, you want him to test it because he will tell you if it's not right. So we went to him, and I literally phoned him and, hi, I'm rewriting the email system so it doesn't suck. Would you like to be the beta tester for it? And he was entirely up for this. So we used the toggle as an experiment. We switched it on just for him. And he tested it for a while, and he found some issues, so we switched off the toggle, fixed things, rolled it out to a new version, and that went back and forth for a week or so. And then once he was happy with it, we added his teammate, who was also a pain, but not quite so much of a pain, and also had a lot of problems with this. And that was fine, and then we rolled it out to the rest of his team. This should be noted, this is a vague representation of the org structure. It was much bigger than this. When we had the whole team running it, we found a performance issue. Now, each user was pushing messages onto a single queue, and then a worker was reading things off. The downside is if the pink user had stuffed in a load of, say, 100 emails at once onto the queue, because they could do mass mailing, which they did a lot, And another user was on the phone with someone and said, yeah, I've sent you the contract, I've clicked the send button, it should be with you now. And Exchange is for some reason taking 30 seconds to send an email and there's 1,000 of them queued up beforehand. It's not great. So we solved that problem by having 2 queues. Still only 1 worker process, but the worker process is just set to read from the direct queue, and if that's empty, read from the bulk queue. And the software is just reconfigured so that when you send a mass mailing, it goes into the bulk queue. So at this point, we've now solved a performance problem. That team tested it, and when there were no new problems, we rolled it out to another team, and then to their department, and then to the whole organization. Now, this whole process took us about 6 to 8 weeks. I mean, we weren't constantly working on it because, you know, he might be fine with it for a few days, and then he'd report, hey, this formatting's wrong. So, you know, wasn't my sole focus, but it took, 6 to 8 weeks. Once the whole company was on it for a few weeks and no new problems, we deleted the toggle. And this is a rough graph of what the usage looked like. So on the left, or on the y-axis, we have the percent of users who've got the toggle enabled, and on the on the x-axis, we have time. And you can see at the beginning, flaps up and down a lot, and that's me testing with that guy testing, and me switching it on and off. And then we get his mate on it, and then the whole team, and then there's the off period where we found that performance issue, and then you can see there's a fairly fast ramp up to the rest of the company, and then suddenly no one has the toggle. And that's us deleting it, because everyone's got it. We don't need to keep it around. So by looking at this graph, we can, and our rollout percentage, we can have our next rule, which is really monitor your toggles. Because you don't know if you can delete it if you don't know if people are querying it. And if you're looking at a toggle, well, no one's querying this, then you can probably delete it. But you might also be looking at things like, how many users have got this? What percentage of errors are we getting from that user? So you might want to correlate it with error logs or monitoring. If you have, has anyone heard of the Scientist library by GitHub? Oh, only a couple of people. So Scientist is a way of, there's a couple of .NET versions of it as well. It's a way for running experiments in parallel with existing code. So if you had a function for sending emails, you could write a second function that sent emails in a different way, and Scientist would run both of them, use the results of the existing version, but report both versions' performance characteristics back. So you could see if the error rates were the same or if one was faster than the other. So if you're going to be doing experiments, you might want to look into that library. Again, this is displaying really weirdly on my screen. It's clipping half the diagram off. But it's fine here. Right, so this is another one of the graphs we're looking at, which is the rate at which a toggle is queried. So we can see, to start with, most people have the toggle off, and everyone is querying this in the company. So the reason we have an angle at the start and the end of this is because when we deploy software, not everyone gets the new version at exactly the same moment. So the number of queries does ramp up over time. But we're also looking at what percentage of users have a toggle set to on or off. So if it stays, loads of people are querying it, but it's on, or loads of people are querying it, but it's off, then we can delete it. But also, if no one's querying a toggle, then it can be deleted. And I guess that's what I'm trying to get down is keep your toggle lifetime short and delete them. Deleting stuff's great. Yeah. The final part on that, which still relates to the monitoring, is alerting. If you're using something like Graphite and Grafana, you can set up monitoring on that, and Datadog can do similar as well. Monitor your toggles. Figure out what your time window is, and send an alert when something hasn't been queried for a few days. That way you can proactively delete your toggles. Because the more toggles you have living at the same time, the more overlap you're likely to have, and the more overlap is going to give you exponential more code paths. And more code paths makes more complex. And this is rendering really weirdly now. Okay, I can't see anything. Yes, user perception. So when you're rolling something out with a feature toggle, one of the side benefits from this is user perception. So our first user, the one who was a pain, he feels special because he helped design this new feature. He helped build it. His feedback mattered. He built this feature, so he feels really great about this. The early adopters they feel great as well. We had early access. We're a part of a special group. We got all this new stuff, and it was great. Everyone else also feels great, because as far as they can tell, we switched on a new feature instantly for most of the company at once, and it just worked. I mean, they don't know that it took us several weeks to make it perfect, but to them, the perception was everything just worked at once. So not only are we deploying software in a more stable manner for us, but it's helping the user perception of what we can deliver. So yeah, harness this kind of good feelings from users, as well as, well, feature toggles are fun to write, so everyone likes it. The downside, which I've alluded to a few times, is the number of code paths goes up. And a lot of people say that they don't like toggles because of the additional complexity that it adds. The first comeback to that is we're software developers. What doesn't add complexity? Apart from deleting things, which is great fun, and we generally can't remove complexity very well. Like Dylan Beattie was saying in his talk, is that we don't have to think about how the atoms and the electronics of the processor work anymore. It's not removed complexity, it's just abstracted out of the way, most of the time. So we can try and abstract as much stuff out of the way as possible, and we can use toggles to help do this. We can also use toggles to trade one kind of complexity for a different kind of complexity, one that's hopefully easier to deal with. Now, this is the same company that had the email rollout, and this happened after the email rollout. So I'm probably at least partially to blame for this. So we had 3 very long-lived feature branches, and by very long-lived I mean years. And I heard from one of the, I don't work there anymore, but I heard from one of the developers recently that the outsource branch still exists, which puts it at about 5 years old. Probably still with only 2 commits, because I'm not convinced they've learned what Git is yet. I believe they threaten people with that branch. Like, if you don't do this, then you have to merge that branch. Oh, okay. I don't even need to put the branch on there, it's just amusing. So we have these 2 internal feature branches, which were very long-lived, and the business said to us, right, we want the second internal feature is considered done, we want it released. Now, as we were releasing everything off master, we did the logical thing, which was merge it in, and then we rebased the second internal feature off of the master branch. And then someone priorities changed, and actually internal 1 wanted to go out, but not internal 2. Have you ever tried to undo a rebase? It's not the most fun. And this happened several times. After like the second time, we were like, right, let's not rebase anything until it's actually in production and they're actually decided to keep it. And like I said, this is the same company that had the great email rollout. Why didn't we use feature toggles for this? We could have kept merging all these little features, because there were lots of little things in these 2 major branches. If we'd kept merging them into master and had them behind toggles, then we could have flipped between whichever feature was desired without affecting very much. I mean, sure, you're going to take on a bit more complexity, especially if your data is changing. So if you have structural database changes in both branches, you're going to take on that complexity earlier, rather than later when it gets merged in and suddenly you've got 2 incompatible sets of changes that you now need to resolve. So while it would be painful earlier rather than later, and hopefully less surprising. So yeah, don't have long-lived feature branches. In fact, don't have branches that live longer than a day or 2. Really. Do trunk-based delivery. The next piece of feedback I receive a lot is that feature toggles make testing harder. And maybe? I'm not convinced I agree. So let's say you have some kind of tests, doesn't really matter what. And we treat our tests as an immutable artifact. So we decide to add a feature toggle that does something to some class. So what we do is we duplicate. We copy and paste the set of tests into a new class and call one of them toggle off, blue, and one of them toggle on, green. And then we change the tests in green to match whatever the new feature should do. We release the feature, and both sets of tests should compile and pass, because one's with the toggle off, one's with the toggle on. Once your toggle has been used for a while and you decide that your experiment's been successful or a failure, as it might well be, and you decide to delete the toggle, you just delete the relevant tests and you've gone back down to one set of tests again. It doesn't make it that much more complicated for that long. If you're doing manual testing as well, like following a test script or something, it's basically the same. You just have two test scripts. When the toggle is on, this should happen. When the toggle is off, this should happen. Throw one away when you get rid of the toggle. Now, the only time this really breaks down is if you've got a feature flag that is spanning multiple microservices. And the way you solve that is by not doing it. Because if you have a feature flag that has to span multiple microservices, I think you've got your bounded context wrong. Because you shouldn't need to affect another service. And if you do, maybe you should have two separate toggles, one for each service, and one service has to take the responsibility of, I need to handle both states from this, but then I can decide whether my output should match or not. So I'd say if you've got toggles spanning multiple services, you've got at least a code smell, but probably a bounded context smell. I don't know what the term is for that. So yeah. As a brief recap, these are the rules. The first one is really, really important. Ask anyone who worked for Knight Capital. And the next 4 are also important. And monitoring them you could probably get away with without. My current team don't use feature toggles as much as I'd like. We actually deal with them by using Octopus deploy variables in our web configs, because we don't have them that often. It's usually we've written a feature and we need to wait for another team to deploy their feature before we can switch ours on. So you can start with a very simple fashion. Just use a web config setting. As you start to want to do more things, like experiment on a specific user or group of users, that's when you need to start looking into other services like Launch Darkly or other alternatives. I actually don't know of any other alternatives. I'm writing a feature toggling service. My advice on that is don't use it, because it's just me messing about as I'm bored, and it's got no real design or purpose or anything. So if you want to laugh at me writing feature toggling services, look at my GitHub. It's called Crispin, for reasons. And finally, I've got some links here. The first link is a more in-depth review about what happened with Knight Capital. It's a fascinating read. The second link is the HP LaserJet talk as well, which is also a book, which is also fascinating, and that goes into the real dynamics of how they changed into an agile organization. And then we've got some more information. Definitely do trunk-based development. I don't think I've mentioned that yet. Do trunk-based development. Yeah, so that's all I had. And any questions, I guess? Yep.
You're talking about monitoring the usage of your toggles, but you didn't quite go into how you actually do that monitoring.
Yeah. So the question is, how do you monitor toggles? It depends. If you're using some kind of structured logging or centralized logging, so we log everything with Serilog and push it through to Elasticsearch, so you can log your toggle states with that. Or we also do monitoring, so if you're using the Graphite or Grafana stack with like StatsD or Datadog, for instance, you can push metrics through that as well. So you basically collate them into one location and then build a graph for them. If you want, I can show you some graphs afterwards, but I don't think I'm technically allowed to publish them. But yeah, there are existing tooling for that. Don't invent your own. As fun as that is. Anyone else? Sorry, I can't see because of the sun that's over there. No, that doesn't look like anyone else. Okay, so thank you very much for coming.